Okay, moving on to problem 11.2 in Unit 6, Lesson 11. What we're asked to do is consider two functions, complete the table of values for each function, then we're going to determine the x-intercepts, the vertex of each graph, and explain how we know. And then after we do that, we're going to take the points that we got from those table of values and we're going to plot them on this coordinate plane. And we're going to make a couple observations about how the graphs compare. So let's look at this first function. We have f of x, we'll make this one red. We have f of x is equal to x times a quantity x plus 4. Okay, so to graph this, to build a table of values, what we need to do is we need to take each one of these x values and we need to plug them in to our function. So for example, how did they find whenever x is -5, the value of the function f of x is equal to 5? Well, they simply plugged it in. So let me show you how we do that. We just take f of -5. Everywhere I see an x, I'm going to write -5 is equal to -5 times -5 plus 4. Now I simplify this. The -5 on the outside stays the same. Using PEMDAS, I need to simplify what's inside the parentheses. -5 plus 4 is -1. Now I have -5 times -1, that's positive 5. That is why the point -5, 5 is on my graph. Now, in Algebra 1, you did a lot of building tables of values, and you did it a lot by hand. I would encourage you not to do it by hand. If you do not have a graphing calculator, you certainly can do it by hand, but I'm going to use the graphing calculator. And here's what I'm going to do. I have the first function entered in to my y1. So let me show you, if I clear this function out, go to the home screen. Here's how I'm going to put this function into my calculator. So the first thing I'm going to do is I'm going to go to the y equals, and I'm just going to type in x times the quantity x plus 4, just like I see it. X, parenthesis, x plus 4, close parenthesis. Hit enter. Now, I can use the table function on my calculator. Notice graph, if I hit graph, it'll graph that function, but I want the table, so I want the second function of the graph key. And here's my table. I can just copy this table of values. Notice whenever x is -5, y is 5. Whenever x is -4, my y value is 0. Okay? And I can do this for every single value in my table. So -3, -3, -2, -4, -1, -3, good. 0, 0, 1, 5, 2, 12, 3, 21, 4, 32, and 5, 45. So look how easy it was to build that table of values. Now I'm going to do the same thing. I'm going to build the table of values for my next function. Go back to the y equals. The only difference is that this is subtract. So I'm going to scroll over, and I'm going to put a subtraction, not the negative, subtraction. Now I'm going to go hit enter, go back to my table, and I'm going to mark these points down. -5, 45, there it is. Then I have -4, 32, -3, 21, 2, 12, -2, 12, -1, 5, 0, 0, 1, -3, 2, -4, 3, -3, 4, 0, and 5, 5. So there are my two functions. Okay, now what we want to find are the x-intercepts. Let's start with that. Let's start with the red one, the one on the left, function f. Remember, the x-intercepts happen whenever the y value is 0. So my first x-intercept is at -4. My next x-intercept happens when the y value is 0, is an x value of 0. So those are my x-intercepts. How about the vertex? So remember, the vertex happens to be the highest or lowest point on my graph. So if I'm looking for the vertex, I'm looking at where do my y values change direction. So I go 5, then 0, -3, -4, -3, 0, 5. Notice that I'm changing directions here. My y value is getting smaller, 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 smaller. Then it starts getting bigger. Where it changes direction, that's going to be my vertex, and that happens to be -2, -4. So that is the vertex. And we'll be able to tell better when we get this on the graph. So those are my guesses. Now if we come over to the green one, first we're looking for the x-intercepts. That happens whenever the y is 0. So I can see my first x-intercept is x equals 0. My second x-intercept, wherever y equals 0, happens at 4. Now if I'm looking for my vertex again, I do the same thing. I want to find the highest or lowest point on the graph. And looking at this graph, it looks like if I go, it's getting smaller, 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 reaches 0, still smaller, still smaller. Now it's getting bigger. So I see for this vertex that this happens at 2, -4 as well. Okay, so this vertex is also at the point 2, -4. Okay, now what I want to do is I want to plot these points on our graph. Okay, so I'm going to zoom out here, and I'm just going to start plotting the red points, -5, 5. So if I come over to -5 and go up 5, perfect. Pay attention to the scale on your axes. Okay, going left and right, every line is 1. Going up and down, every line is 5. -4, 0. -3, -3. So that's like right about here. -2, -4. Right about there. I have -1, -3. 0, 0. 1, 5. 2, 12. 3, 21. 3, 21. 4, 32, so 4, 32, and 5, 45. Okay, so there are the red points. Let's now plot the green points. I have -5, 45, -4, 32, -3, 21, 21. I have -2, 12. I have -1, 5. 0, 0. I have 1, -3. I have 2, -4. I have 3, -3. I have 4, 0. And I have 5, 5. So those are the green points. Now, we're asked to make a couple of observations about how the two graphs compare. Well, the first thing I notice, they both have a y-intercept at the origin. So they both have a y-intercept right here at the origin at 0, 0. The next thing I really notice is that the red graph looks like a reflection of the green graph. So notice how the red graph and the green graph are kind of mirrored, and they are mirrored across this line across the y-axis. It's kind of a mirror image across the y-axis. So those are just a couple of observations that I notice when I compare these two graphs.